Good afternoon. Hope everybody's doing well. It's today, as announced in our module and also in the email that I sent last week, we're gonna have our third exam for this semester on Thursday, April 29, and the exam will be within the time period for this class, the scheduled time for this class. From 5 p.m. to 6:30 p.m. And the exam will have two sections as listed in the PowerPoint. We have in the first section we have the multiple choice or true or false questions. There are going to be 10 questions that are going to be worth 2 points each. So in total, you will have 20 points for this first section. And then in the second section, you will have up to three problems that could be short answer, explanation, description, or mathematical. So as you have seen in the first two examples, these are questions that are similar to the questions that I discuss in class, or that are those questions that are part of the assignments for the class. So in this third part of the semester, we have lectures 9, 10, I believe 11, up to 12. So that will be the topics that are going to be tested in the exam, starting with lecture 9, which is the material handling equipment. For this particular lecture, we didn't have any assignment, but the idea of this lecture was for you to get familiarized with the names of some of the material handling equipment that is very common in facilities and warehouses and so on. So for this lecture, it's important for you to at least understand what are the major groups of material handling equipment and how are they different. How are they used in practice? So what are the applications for them? So if we talk about forklifts, so the purpose of a forklift is material movement, material handling, moving from one place to the other to another. So this is one type of equipment that can be useful for those purposes. We talk about the different type of racks, different type of cranes, and so on. So understanding the differences between them and knowing what they do is what I'm trying for you to understand from this lecture. So questions for this lecture will be mostly from this first section of the exam. So I can ask you a multiple choice question, give you a brief description of one group of material handling equipment, and I ask you to identify what will be the equipment that will be addressing that particular issue in a warehouse, for instance. So that's for lecture 9. Lecture 10, we talk about conveyor models, and we had an assignment for this material. These are trolley and similar conveyors with discrete carriers. So the idea it was for you to understand if you were to design a conveyor that has a carrier that has specific capacity, based on the data that you have for your process, the amount of product that are going to be arriving to the conveyor, how much capacity would you need for the carrier to be able to run your process? So we have two type of problems here. We have a conveyor with deterministic loading and unloading sequences. And then we have a case in which we are considering the probability, the uncertainty with the Poisson arrivals. So for each type of problem, we would discuss a methodology, a heuristic to address those problems. We went through a couple of examples in class in the lecture video. I also recorded an additional video for another example. So you can find that additional video also in the modules. And there were a couple of problems in the assignment. So my advice is for you to go over those examples and understand the steps that you have to do in order to achieve the final answer for both type of problems, for the deterministic case and for the Poisson arrivals. Then we had lectures 11, part 1 and part 2. We would discuss warehouse operations. We talk about the mission of a warehouse, the functions in the warehouse, the receiving and the shipping operations, and the storage operations, or the storage space planning. So in here we have also some interesting design problems. For example, one of them was for you to tell me if you have a facility space that you can partition in different, you can partition the space in small areas. So using the heuristic or the proposed heuristic that is based on an optimization model, tell me which products will be located in which cell of this space. So that was one of the problems that you needed to solve, and also understanding the difference between planning for dedicated storage and randomized storage. So if you were to plan for dedicated storage, how much space would you need? Or if you are planning for dedicated storage, how much space in terms of space for the product would you need? So those are the major problems that were discussed in these two lectures. We have examples in the lecture videos, in the slides, and also in the assignments. There were problems associated with this, and we're gonna talk about those in a minute. And then finally, lecture 12 was on the single facility location model. So here in this lecture, we are basically going outside the facility, and we are thinking about if you were to place a new facility for your company, and then knowing about the demand and the distance from your clients to the distances to the possible locations to identify the best location for this new facility. And this is the last part of the class semester of the class, and also for the third part of the semester, which is the material that we are going to be testing on Thursday. So that's in terms of the material for this third exam. In terms of preparation for the exam, I encourage you to look at the lecture slides, the labs, and the assignments. If you need any formulas, I'll be providing those in the exam. And the exam is closed books and notes. The link to access the exam will be available in the Canvas modules, like we did for the first two exams. Clearly show your work and formulas using your solution, because this helped me to award full or partial credit. And then the multiple choice and true or false questions will be answered using the computer. And I'm sorry, this should be three. The three problems or questions, for those, you will be uploading a file So you will be working on a paper, you would be answering or doing the computations in a piece of paper, and then you're gonna take a picture or scan that piece of paper and you're gonna upload that to Canvas. So you will have 15 minutes to upload the files. So the exam will last until 6:20, and then you will have the time after that from 6:20 to 6:35 to upload the files. So the exam will close at 6:35. So make sure that you make the best use of your time. I don't anticipate you taking longer than 80 minutes to complete the exam. So you should have enough time to upload the files. So make sure that you do you upload those files on time. And then I included the following slide just as a reminder. For this class, the final project is optional. I'm sorry, the final exam is optional. So if you do very well or if you did very well in the first 3 exams and you decide to keep your final, your grade after computing your course grade with the 3 exams, the homework, and the project, then you can keep that grade. If you decide to do that, like for example, you got an 85 and you're fine with the B, so you don't have to take the final, or you got a 95, so you got an A for the class, so you don't have to take the final. So I'm going to be computing that grade as soon as you submit your project and you finish the exam. I'm going to be working on grading those 2, and I should be able to give you feedback on your grade by Monday next week. So using that information, you can make a decision on whether or not you want to take the final. So if you, for example, got after completing the 3rd exam and the project, and you end up, let's say, getting a 78, 79, I will encourage you to take the final because that can help you improve your grade. But if you have, let's say, a 71 or 81 in the class after grading the 3rd exam and the project, if you have 81, taking the final might not, it will not help you to get to an A. So I just want you to be aware of that information. So you can take the final anyways, but if you take the final with an 81, with hopes of getting to an A, you can do the math and you will see that it's not feasible. So my advice for those would be not to take the final, but again, it's up to the student. So you can look at the details for this in the syllabus, but this is coming straight from the syllabus. So if you, again, I'm going to grade the exam and the project, you should get feedback about your grade for the class without the final by Monday. And then by that time, you should be able to make a decision. You don't have to inform me about the decision. The final exam is going to be online. So if you decide to take the final, you just have to log in on the day of the final and take the exam from the computer. So if you take the exam, then I will be grading the exam and I will be used that as part of your grade. If you don't take the final, then I assume that you are not going to be taking the final. So I'll be computing your grade with the exams 1, 2, and 3, the project, and the assignments and labs. Any questions?
No.
Good. So what I have left for the review is to go over some of the problems, the latest problems from the assignment. So In this problem, we have 12 products that are received by a warehouse according to the schedule in table 1. So we have these time periods from 1 to 20, and then we have 12 products. And we want to find the storage requirements for dedicated and randomized storage. Okay, so as I mentioned already, as part of the review, there's a difference between how you plan for dedicated and randomized storage. So for dedicated, you should expect to have more space because you're making sure that you have enough space for each one of the products in your company. So for these 12 products, I want to make sure that I have enough space in my warehouse. But when you look at randomized storage, that's not the goal. The goal is that you're going to be sharing space, and you want to make sure that if you have at some point a high volume of items in your facility, that you have enough space to accommodate that high volume. But you are not planning to have enough space for each one of the products. So that's the difference. With this in mind, since my pen is not working for in the computer, what I decided to do was to share the screen here with the way that I solved the problem with the problem that we discussed in class. So for the dedicated space, we want to make sure that we have enough space, right? So we are going to be looking for the maximum quantity for each product for all the time periods. So for example, here, product number 1, I'm looking for the highest or the maximum value that I observed for that product, and that will be 24. For the second product, for all time periods, I found that for the second product, that will be 36. For the third product, that will be 8. For the fourth product, that's 24. For the fifth product, that's 24. And for the sixth product, that's 24. So for dedicated storage, I find this summation of the individual maximum inventory levels. So that will be the summation for product 1, product 2, 3, 4, 5, and 6. So you'll do the same thing here. For this, you're going to be finding the maximum for each one of these products. So in this case, that will be 45. And in this case, I believe it's 38. I'm sorry, 47. And then you continue that process. And then at the end, you sum those values for all products. And that summation should be equal to 571 pallets. And then with randomized storage, you are going to be, again, let me go back to this. So for randomized storage, you're going to be looking also, you're going to be summing for each period. You're going to do the summation for the total for each product. So in this case, you have the summation is going to be 73. The summation is going to be 66. So you do that summation for each time period. And then once you have the column with the summation, you're going to find the maximum of that column. So in this case, that's 105. So for a randomized storage strategy, the number of, or the space that you will need is space enough to accommodate 105 pallets for this problem. So if you solve this problem, you're going to have to solve for each period. You're going to have to find the total for each row. And then looking at the total for each row, you're going to find the maximum amount. And that maximum amount is going to be the space that you're going to need for the randomized storage. So in that case, that will be 385 pallets. Any questions? Okay, so
no, that was good.
Excellent. So on the next problem, so this is the problem that I was also mentioning that was part of the assignment. So in this case, you have a warehouse facility, and you have two doors, dock 1 and dock 2, and you're trying to, based on the information that you have for each product family, you're trying to decide where to place each product family in the facility. Okay, so we have several pieces of information here that are needed for you to solve this problem. So starting with the area that you have available. So you know that each square is going to be 20 by 20, and you have these many cells in the warehouse based on that area. You have the location of the doors, and also you have information about the product family, the space you need, and also the loading rate. So the first thing that we have to do is to let's start with looking at the warehouse, the space that you have available. The first thing you want to do there is to find the distance from the door to each one of the cells centroids in this space. Okay, so you know that each square is 20 by 20. So if you go from door 1 to this space right here, the first cell, you will be walking from here to here is 10, and then you have, 20 plus 10 to get to the center of the square, and then 10 more. So in total, you will have 40 for the first door, and then you have to do the same thing from this up to the center here, and you multiply, assuming that 50% of you using any of these two doors. So you multiply 50% times the distance to door 1, and then plus 50% the distance up to door number 2. And you do that process for each single cell of the facility. Obviously, I know this is time consuming. So if I ask you to solve something like this in the exam, it's going to be a small instance of a problem, or I can ask you to complete a problem that doesn't have all the information in it. So I'm aware of that. So once you identify the distance from the cell to both of the doors, then you can create something like this. I did some coloring in this solution just to show the differences in distance. So light blue starts with the shortest distance to both doors, and then as it gets dark, the distance starts, and then I change the colors. So you get the idea. So what this represents in terms of from a practical perspective is, if you have, or the idea in this problem is to identify those products that are the ones that are moving the most, let's say those that have the highest demand. You want to identify those products, and you want to place those products in these cells that are located closer to the doors, because you know those are going to be moving quicker. And if you have a product that has a high demand, you don't want to place them in this corner, because it's going to take you more time for you to access that product and also to move that product to the doors. So you want to identify those products that have a high demand or have a move rate that is faster than the other product families. And you want to make sure that you put those in those cells that are closer to the docks. So they can be accessed easily. So going in that direction, now we use the information from the products to identify which, or to rank the products in terms of the loading rate. So this is the information that is given. As you can see, the area that is required for each product family is given as a total area, but we had to find a way to make it consistent with the grid that we have for the facility. So how do you go about that? You look at the area and you know that each cell measures 20 by 20, so that's 200. I'm sorry, 400. So using that information, you can divide 400 feet square by the area needed by each product, and you can identify how many cells are needed for each product family. So that's what we did here. We have the number of cells that are needed by each product family. So in the first product, we have 6, second product 8, third product 5, and so on. That's gonna be our SJ. We're gonna need the SJ to determine the ratio for or to rank the products. So we have SJ, the loading rate is given. So using this information, we can define this ratio. And I have the values here for the ratio. So 600 by 6, that's 100. 400 by 8 is 50, and so on. So using this information, now I can rank my products in terms of loading rate. And in terms of this ratio that considers the load rate by the space. And we can identify as the product that has the highest value is product number 6. So 6 is going to be first. Then we have product number 3, number 1, number 4, and number 2, and then number 5. So that's the ranking. You can see the product ranking here. And now using this ranking, I'm going to start locating these products in my warehouse. So how do you go about that? Well, you find product number 1, I'm sorry, product 6 requires 4 cells. So you want to make sure that you reserve 4 cells in the 70s for product 6. And that's what I did, 6, 6, 6, 6. So I have here the 4 cells for product 6. And then next goes 3. 3 requires 5 cells. So I still have enough 70 value cells. So I'm going to place product number 3 in those. So I have 3 here, 5 3s. Then I move to 1. 1 requires 6 base. So I still have 3 70s. So I place the ones there, and I still need to place 3 more. So I go to the next value, which is 80, and I place the ones in the 80 cells. And I'm done with 1, and then I go to 4. 4 requires 7 cells. So I have 4 cells that are 80, and then I need to find 3 more for 4. So I have 90 here, and I have 200s here. And then you continue this process until you complete the assignment for all the products in the facility. Okay, so that's how you go about this problem. Any questions? Okay, and I want to make sure that you understand something. So for those students that are industrial engineering students, you're familiar with operation research. So as you can see here, we have a linear programming form. I'm sorry, this is not linear programming. This is an integer programming formulation. Decision variables are x, I, j equals 0 and 1. So this is the formulation for the problem. If you input this formulation and this data into Excel or into Cplex or Ample, you should be able to solve this problem using the branch and bound algorithm, for example. But I don't know if you took operation research with me or not, but there are certain problems in operation research that you can solve using a heuristic. And what we have discussed here is a heuristic model. Basically, what this does is using this algorithm, this product ranking and the sorting, using this algorithm, you can find the optimal solution for the problem without having to go and solve this problem in Ample or Excel or Cplex. So if you solve the optimization problem you should be able, with this data, you should be able to get the same solution that we are getting for the heuristic. I just wanted to mention that. So that's why we are showing the formulation here. The purpose of this class, I know that there are some students that are from manufacturing, for instance, so they don't take operation research. So for the purpose of the class, I'm asking you to solve the problem using this heuristic. But if you would like to try it, you can also go this way and solve the problem using branch and bound, or using one of the commercial software packages, or Excel, for example. But you don't need that for the exam. I'm just mentioning this for information purposes. And because it's the same thing that is happening in this problem. This is a facility location problem. We have a formulation for this problem. It is in the lectures. But again, for this type of problem, there's a heuristic that will also solve the problem without the need for you to access a commercial software package. So you can solve this by hand using the heuristic. So the idea here is you have the information about the centers, the XY coordinates for the existing facilities, and also you have a weight, meaning that this new facility, if it is having a higher weight, means that you want this new facility to be closer to that center. I'm sorry. So for example, my new facility should be closer to center F because there's a higher weight associated with that center. There might be a reason for that. Maybe you have a warehouse there and you have a customer that has a very high demand for the product that is located in that warehouse. So you want to make sure that that new facility is located close to that warehouse, and so on. So the information we have is the XY coordinate for the existing facilities, and also we have information about the weight in terms of the importance for this new facility to be located close to these centers. So the heuristic, how it works, we take the information in terms of the X and Y coordinates, and then we sort that based on the distance, right? So we have center I here. So for coordinate AI, we have sorted this information. So you see 5, 15, 25, 30, 35, and 50. So we sort the information based on this. Okay, and you see how the centers are no longer in the same order, right? Because they were sorted using this coordinate information. Same thing here for the weight. Okay, so we do the same thing for the Y coordinate. Okay, so we sort based on this coordinate, and you see the information now for this is again sorted based on the coordinate. And the ratio that we're going to use, or the measurement that we are going to use to identify the X and Y coordinate for this new facility is going to be based on this formula. It's going to be 1/2 or times the summation of the WIs. So we're going to sum the WIs, the weights, and we're going to divide that by 2. So in that case, in this case, that's 1200. So this is going to be our cutoff point, 1200. So what we are going to do now is going to start adding or aggregating the values for WIs from this point to this point. So 200, 600, 1100, 1700, 2000, and 2400. And we do the same thing for the Y coordinates. We do the aggregation for all until the last center. And now using this cutoff point, I need to identify which coordinate or where in these aggregate values I have a value that is greater than 1200. So in this case, that would be this value, 1700, and that is associated with this coordinate value of 30. Do the same thing here for y, and I look at the value that is the first value that is higher than 1200, and that will be 1300. So that the coordinate that is associated with that value is 20. So my new facility will be located in this new coordinate 30, 20, and that will be the solution for your problem. That will be the location of the new facility. Questions?
We're not gonna have any like conveyor type problems then? That's still fair game?
Which ones?
The conveyors, it's the, let me see, the chapter
21. the conveyors problems.
Yes.
You see, I will not discard those as potential problems for the exam. I know they're long. So if I ask you something about those problems or something similar to those problems are gonna be questions that I ask you to complete, let's say, a step, or to identify a step, or to identify a value based on the process. So it's not gonna be you solving the whole thing from scratch. It is going to be, okay, I give you certain information and I tell you, okay, well, what would be the value for this parameter, for example, or complete this step of the process, for example. So you need to know how the process and how the solution works.
Okay, thank you.
Good. Any other question? Okay, so the video is going to be available tonight. I'm going to post the video, and if there's no other question, you can email me today and tomorrow. I will get back to you soon as possible, and then the exam is going to be available on Thursday. Have a good rest of your afternoon, and I'll talk to you soon.
Dr. Perez.
Yes, yes.
I was wondering if I could talk to you about the part 3 of the project.
Yes, I can stay connected and we can talk.
Okay.
Thank you, Professor. Take care.
Okay, bye-bye. So let's just wait until.
Okay, sounds good.
Unless they still on, I can make us go to a different room. Let me see.
I wanted to go over the project as well.
Okay. So let's assume that everybody here that's staying are gonna ask questions about the project, so we can talk now. Let me stop the recording.